Good day, Grim Reapers. Our mission is to prevent Jay on committing suicide. He is currently at high-risk level. That means anytime now, he could kill himself. So we need to hurry.
This case is not going to be an easy one. We need to elaborate first some code-related methods in order to unlock our respective assignments, fellow Grim Reapers.
The assignments are already sent to all of us. Let's do this.
So for step 1, I have encoding and decoding. Encoding means the creation of a messages which you want to communicate with other person. On the other hand, decoding means listener or audience of encoded message. So decoding means interpreting the meaning of the message. For example, a breakfast cereal company want to convey their message to you to buy its product. The difference between encoding and decoding involve the following. First is encoding is essentially a writing process, whereas decoding is a reading process, and encoding breaks a spoken word down into parts that are written or spelled out, while decoding breaks a written word into parts that are verbally spoken. In the mathematical literature, an encoding or coding is a mapping of an arbitrary set A into the set of finite sequences or words over some alphabet B, while the inverse mapping is called a decoding. Oh, it's unlocked! Okay, here is Jay's profile. He is a bartender, 30 years old, 6 feet tall, and lives in Boston. But wait, he's not in his house. So, Blossom, find his current location.
Errors and error correction? Alright, so this is how it goes. Whenever an input data is not the same as the received output data, this means that there's a mismatched data. And that mismatched data is called an error. These errors can corrupt a whole system or can cause serious problems in transmitting information. But there's a way to fix these errors. Now, error correction codes are used to correct the errors present in the received data bit stream so that we can get the original data. Error correction codes also use the similar strategy of error detection codes, for example, the Hamming code. But in comparison, error detection is the detection of errors caused by noise or other impairments during transmission from the transmitter to the receiver, while error correction is the detection of errors and reconstruction of the original error-free data or signal. Alright, it's unlocked. I can now locate his current location. Let's see. So now Jay is on Allegria 4th Street, Phase 1. Alright guys, we're zooming in.
Now, error detecting codes are used to identify errors in the data bit stream received. Some bits are appended to the original bit stream in these codes. Before delivering the message through the noisy channels, error detecting codes include that when a message is sent, it is possible it will be jumbled by noise or that the data will be distorted. To avoid this, we use error detecting codes, which are extra data added to a digital message to help us in the detection of any errors that may have occurred during transmission. Error detecting codes are used for preventing the user from entering invalid input. Without this, the program will be prone to error. Error detecting codes act as a guard against errors. Parity and Hamming codes are two examples of error detecting codes. Okay guys, I can see through his past now. So Jay came from a poor family. His depression rooted during his 8th birthday. There's these promises that his father failed to fulfill. Fried chicken is the key object in this case. The unfortunate events keeps on happening to him up until now in the present.
Hold on, Jay. Let's see Hamming codes. Okay, Hamming codes is a block codes that is capable of detecting up to 2 simultaneous bytes errors and correcting single bytes errors. In this coding method, the source encodes the message by inserting redundant bytes within the message. These redundant bytes are extra bytes that are generated and inserted at specific position in the message itself to enable error detection and correction. Encoding a message by a Hamming code, the procedure used by a sender to encode the message encompasses the following step. Step 1. Calculation of the number of the redundant bytes. Step 2. Positioning the redundant bytes. And step 3. Calculating the values of each redundant bytes. Ina, Rimar, you two. You have to enter one of the timelines to give Jay a fried chicken. Alright?
We're almost there. Redundant
bits are extra binary bits that are generated and added to the information carrying bits of data transfer to ensure that no bits were lost during the data transfer. The number of random bits can be calculated using the formula where R is equals to redundant bits and M is equals to data bit. Suppose the number of data bits is 7, then the number of redundant bits can be calculated using 2 mean 4 greater than 7 plus 4 plus 1. Thus, the number of redundant bits is equals to 4. Parity bits. A parity bits is a bit appended to a data or binary bits to ensure that the total number of ones in the data is even or odd. Parity bits are used for error detection. Quick, let me enter in J's pass.
This is the last one, guys. We will surely save J. But first, one of the most fundamental error correcting codes is the repetition code. It can automatically adjust the varying channel capacity by sending more or less parity information as necessary to overcome channel noise. And it is the only such code known for non-erasure channels. Repetition code is well known for repeating the message several times in order to transmit a message over a noisy channel that may interfere with the transmission in a few places. In the majority of cases, repetition code is not an efficient coding process in data transmission. However, in a mobile radio where the mobile unit travels from a slow speed to a high speed, repetition code shows a unique property that is suitable for mobile radio communications. So, it is still convincing that repetition code is the proper coding method to use in cellular control data transmissions. Alright, let me handle J in the present.
Thank you, God. Thank you, guys. We save him.